In this tutorial, I'm going to explain the meaning of correlation coefficient. This is the hypothetical data. X is brain attitude, Y is purchase intention. You calculate the correlation coefficient, you get a number 0.85. You do a regression, you got a slope of 0.6. For the observation is that we know that the correlation coefficient 0.85 is different from the regression coefficient 0.6, but they share the same direction, namely both of them are positive. So what do these numbers mean? For the correlation coefficient, conceptually it means that the strength of the relationship between x and y. And correlation coefficient is in the range of -1 to 1. And the greater of the absolute value the number is, the stronger the relation is. Quantitatively explain the meaning of correlation coefficient. In generally, it's better square it. So you square the 0.85, you get the number 0.72. It means that the x can explain 72% of the variance of y. So namely that x brain attitude here can explain the variance 72% of variance of the y purchase intention. Okay, now we have basic idea about correlation coefficient. Let's look at the regression coefficient. So conceptually, the regression coefficient 0.6 also means the relationship, the strength of relationship between x and y. Different from correlation coefficient, the B1, namely the slope, can be any numbers in the negative infinity to positive infinity. Similar to the correlation coefficient, the greater the absolute value it is, it means that stronger the relationship is. On the quantitative side, the slope, namely the B1, here is in the example the 0.6, it means the change of y when x changed by 1 unit. So what does it mean? Let's just like put the x as 2. So if you calculate x as 2, you get the y, the number is 3.2. And then you increase x by 1 unit, namely 3. So replace x with 3, you got the y value of 3.8. And the difference is between 3.2 and 3.8 is 0.6. As you can see that 0.6 namely is the slope or the regression coefficient 0.6. So that's what it means. You might question that why the correlation coefficient is different from the regression coefficient, even though the x and y are exactly the same. Of course, there are different perspectives to answer this question. One way to look at that is look at the formulas. On the left-hand side, which is the correlation coefficient formula, on the right-hand side is the regression coefficient formula. As you can see that the numerators are exactly the same across these two formulas. And the only difference is actually is the numerator. So if you do some calculation, you will get the numerator is 3, so both of them are 3. But the denominator is that they are different. So that's why it lead to different numbers for the correlation coefficient and regression coefficient, even though the x and y data are exactly the same. Okay, I think that's it. Thank you for watching. If you have any questions, feel free to comment down below and I'll do my best to answer the questions you might have.